Hello and welcome to my YouTube channel Physics Ki Pathshala. I am here with yet another topic of physics. This topic is taken from the optics chapter from 10th standard of CBSE and State Board syllabus, and today's topic is mirror's equation. Now mirror equation is given as 1 by V plus 1 by U is equal to 1 by F, where V is the distance of the image, U is the distance of object, F is the focal length. Now to prove this, we need to have this diagram. This ray diagram has been drawn for an object which is kept at certain distance, which is away from the center of curvature for a concave mirror. For the time being, you will only look at the image which is drawn first. Don't look at these two images. Don't refer to these two images for the timing. This will be used later. Now for this concave mirror, I have kept an object AB upright on the principal axis. Now we know that to form the image of an object, we need to show at least two rays. Now those two rays can be any two rays, but for the sake of convenience over here we have taken those two rays, one parallel to the principal axis and one which is passing through the pole. Now parallel to the principal axis has been drawn in red ink. When it hits the surface of mirror, after reflection, I have shown it with dotted line. After reflection it passes through the focus. We know that the line or the ray which is parallel to the principal axis comes and passes through the focus after reflection. So I have shown it passing through the focus. Another ray which is incident at principal, we know that the ray which is incident at principal is reflected at the same angle after reflection. So let us say this angle is some value, having some value is incident over here, then angle of reflection will also be same, means these two angles will be same. So after reflection I have drawn this line to be dotted. Now where the two reflected rays intersect, there the image is formed, that we know. So these two dotted rays, reflected rays, are intersecting over here at point say A prime. So here the image will be formed. So A prime B will represent the image of this object, which will be an inverted and real image. That doesn't matter, the image can be of any nature. We have to derive the formula. We can take any mirror, we can keep the object at anywhere, we can have the image at anywhere, that doesn't matter. The formula will be derived in any of the cases. I have taken one of the convenient cases. Alright, so let us see the geometry. Now if I consider that this mirror is of a small aperture. Now what does that mean? Small aperture means this point M should be very near to the pole. So if I consider that the point M is very near to the pole, then this arc MP of the concave mirror can be considered to be a straight line. So if I consider that MP should be a straight line, then you see there are many triangles are formed. So now you have to refer to this diagram. So one of the triangle will be MPF, and another triangle A prime B prime F, A prime B prime F. Now these two triangles, according to the geometry, are similar triangle. You see there are, or rather you can say they are congruent also. These two are right angle, these two are opposite angles, two angles are same. Alright, so you can say that the triangles will be congruent or similar also. So for those triangles we know that we can write the ratio of corresponding sides will be same for similar triangles. So when we will do the proof, we will refer to this diagram. So I will write that in triangles A prime, B prime, F and triangle MPF F, we can write the ratio of corresponding sides. So one ratio I can take this vertical sides, that is A prime B prime, upon the similar side of another triangle, that is MP, should be equal to, maybe we can take the basis. So base of first triangle will be B prime F and base of second triangle will be PF. I call this equation as equation 1. Now we consider another case. We see another triangles are ABP, that is ABP, and A prime B prime P. A prime B prime P. In these two triangles also you see here one angles are of right angle, that is 90 degree, and these two angles are similar, are same. We have considered this initially only. We know that the line which passes through the pole reflects at the, or incident at pole reflects at the same angle. So these two angles will be same, and hence these two angles will be same. So this triangle is also congruent and similar. So for triangle ABP and triangle, likewise we will write A prime B prime P. A prime B prime P. Again we can write the similar ratios, that is AB upon A prime B prime, and base of first triangle is BP and base of second is B prime P. Correct? Now if we consider our equation number 1, this we call this as equation number 2. Now if we consider our equation number 1, the denominator of left hand side is MP. Now look in the picture above. MP, this height is equal to this height. So in place of MP, we can also write AB. So we can say since NP is equal to AB, therefore equation 1 can be written as how? A prime B prime upon AB is equal to B prime F upon PF. B prime F upon PF. Now we call this as equation 3. Now if we see equation 1 and 2, okay, we can do one more modification over here. We can just invert this equation. So I will take AB upstairs and A prime B prime downstairs. Likewise it will be PF upon B prime F, and now we can write this as equation number 3. Now if you see equation 3 and 2, both are having the same quantities, same thing on the left hand side, and hence their right hand side should be equal. So I erase this diagram. So we can write that from equations 2 and 3, we can write the right hand sides similar, that is equal, that is PF, equation 2, maybe first we will write this, no problem, BP upon B prime P should be equal to PF upon B prime F. Now we can do some modification in this. We can see what is BP, what is B prime P, what is PF, and what is B prime F. So if we see this B prime F can also be written as B prime P minus PF. So we will write BP upon B prime P is equal to PF upon, in place of B prime F, we will write B prime P minus PF. Now I once again invert this equation just for the sake of making the derivation little simpler. I can write it like B prime P upon BP. Here also I can write B prime P minus PF upon PF. Now in the picture or in the diagram, if you carefully see, BP is nothing but the distance of the object. So distance of the object is denoted by U, and since the object is on the left hand side of the mirror, it will be minus U. Likewise, B prime P is the distance of object, so this will be V, and since it is on the left hand side, so it will be minus V. And now PF is the distance of focus, so it will be focal length, and since it is on the left hand side, once again it will be negative. So all these quantities can be substituted in this equation. So let us substitute. So in place of B prime P, I can write minus V upon, okay, I write with black pen only, so this will be minus B upon, in place of BP, I can write minus U is equal to, in place of B prime P, once again I can write minus V, then minus, in place of PF, I will write minus F upon, again in place of PF, I will write minus F. So I need to erase this part. I hope this part is clear to you. I am leaving the board for you for some time so that you can refer this picture for some time. You can also go back to the beginning of the lecture and video, and you can refer this there also, no problem. So now I erase this part of the board so that I can continue further with the equation. Alright, so on the left hand side you see numerator and denominator are having negative signs, so they will be cancelling each other and you will have V upon U, and on right hand side we can write it minus V. This minus and minus will become plus F upon minus F. What I do is I split this fraction, so I can write it minus V upon minus F, and then plus F upon minus F. So this will be minus V upon V upon U, and this minus and minus will cancel and you will have V upon F, and here it will be F upon F will be 1, and then plus upon minus will be minus, so this is minus 1. I take this term, that is V upon F, on the left hand side, so we already have on the left hand side V upon U. I am taking this V upon F, so this will be minus V upon F, and on the right hand side it will be minus 1 left. Now in these two terms you see the numerators are same, so I can take numerator common. So inside the bracket I will be left with 1 upon U minus 1 upon F is equal to minus 1. So now I take V on the right hand side, so I am left with 1 upon U and 1 upon F, minus 1 upon F on the left hand side, and I take this on the right hand side, so this will be minus 1 upon V. Now it's just a matter of arranging the terms, and once we are done with arranging the terms, we will be ready with the answer. So what I am doing is I take the second term of left hand side on the right and the term from right hand side to the left. So on the left I will be left with 1 upon u already, and I am taking this 1 upon b, so this will become plus 1 upon b, and if I take 1 upon f on the right hand side, it will be plus 1 upon f. Once again I rearrange it according to our requirement. So this is 1 upon b plus 1 upon u is equal to 1 upon f. So this is what we have to prove, we have to achieve as the mirror equation. So hence proved. So this is the mirror equation. I hope you must have understood the derivation, how it is done. Now this derivation is generally not asked very frequently for 10th standard exam, but it is definitely asked in 11th standard and 12th standard board syllabus. But nevertheless, this is the part of both 10th standard and plus 2 syllabus, so it is an important topic of optics. I hope you must have understood and liked my lecture. So with this, I would request you to like, subscribe and share my YouTube channel with others as well. Till then, take care of yourself, be happy, and thank you very much.